Good afternoon, everybody. Welcome to the Drought Conditions webinar. Thank you, everybody, for joining today. Hopefully you can see the screen and hear the audio. We're going to get started here momentarily. We've got a panel lineup. I see there's 30 plus people on, so we've got a good panel of presenters today to go through a variety of updates on conditions in the state, particularly in Northwest Iowa, as it relates to hydrology and agriculture and drought. And hopefully, as we go through, you will find the information useful. Just a couple of things to point out to you since this is a webinar, and since this is a webinar and not a Zoom meeting like we did the last time, if you want to ask a question, you can use the Q&A box, which is at the bottom of your screen, not the chat box. That's turned off to participants. So use the Q&A box and you can type in questions. We will attempt to respond to those as we go along. If you have a question that you want to ask, just use the little raise hand icon and we'll get your audio set up so you can ask a question verbally. And then we can respond to that. Much as we did the last time we did this back in January, when we're all done, I will collect the PowerPoint or slide decks from folks. I'll have them compiled into a single document and make those available on the DNR website, and Justin may get those up on the IDOLS website as well. But all the information you're seeing in the slides will be available probably on Monday or Tuesday next week. So you can go to the DNR website and just type in water summary update in the little search box, and it'll take you to that page where we should have the information up and available for you early next week. And as I said, if you need anything between now and then, don't hesitate to email any of the presenters today. Myself or anyone else on the panel, and they'd be happy to give you some information afterwards. So with that, I am going to go ahead and get us started. We have Secretary of Agriculture Mike Naig available to open up with a few comments. So I'm going to turn it over to Secretary Naig and have you jump into it.
Well, thank you, Tim, and thanks everybody for joining today. And certainly we know that this drought conditions that we're seeing in the state are continuing, and we know that certainly as we look to the spring planting being upon us here, especially days like today when you see sun shining, you know that it's coming fast. And so in the spirit of looking ahead and in the spirit of thinking about prepping fields for planting and what can be done to put us in a good position for success. Of course, glad that we can have webinars like this. And I want to start by just thanking all of the different partners that are involved here today. Of course, Dr. Glisson, the state climatologist here with the Department of Ag, and Tim and DNR, of course, USGS, the National Weather Service, and the USDA Midwest Climatehub. Thank you all. It's a great partnership. People working together, sharing information and sharing insight and expertise, and you're going to get pieces of that from each of them. So, of course, on a personal level, as you look at those the drought monitor throughout the year, that D3 drought almost creates a perfect little arrow pointing right at our farm in Palo Alto County. So Dr. Glisson knows in particular how personally invested I am in knowing what's happening, but certainly in my role as secretary, we watch very closely what's happening. Just earlier, last week, had visited down in Southwest Iowa, looking in on some of the flood recovery work that's still ongoing down there from 2019. And it just once again reminds me of what a difference a year can make in so many ways, but certainly when it comes to moisture, subsoil moisture, the way we entered 2020, and then the dry conditions that we saw. And now as we enter into 2021 with dry subsoil conditions, what that will potentially mean. So that was just once again brought home to me. I know we've seen a bit of an improvement here just recently because of some snow melt, and that sort of thing. Of course, one thing I like to always watch, and I'm asking Dr. Glisson about, is how much of that is actually making it into the soil. And so we know slower melting helps with that. But, again, I just want to, again, thank you all for participating. Thank all the partners that work together to put this together, but also what they do to work together throughout the year to monitor the situation on the ground. So with no further ado, I'll turn it back to Tim, and thanks everyone for being a part of this.
Appreciate that. Thanks for your comments. You know, as Secretary Nag pointed out, this is an informational webinar. This is put together with only one purpose, and that's to try to communicate information to those who need to hear it. So in the spirit of that, we're going to jump into the agenda. And again, this is intended to give a good overview of what the conditions are out there. And if you have a question as we go through, please feel free to hit the raise hand button and we'll get your audio set up. Before we hear from Justin Glisson, I'm going to open up one of these polls. And I have a short poll basically to collect some information from anyone who's willing to do it. It's an anonymous poll. It just gives us some data about what your perceptions are as we start the meeting. And then toward the very end, I've got another poll that I will release that does the same thing. So we'll try that at the end as well. So I'm going to hit this launch polling button, and you all should see that. I'm just going to leave that open for a little while. So as you listen to Justin, you should feel free to fill that out. It's not particularly onerous, so hope you can do that for us. It just helps us do a better job in planning and getting things ready to go. So hopefully you all can see that. Justin, I'm going to turn this over to you. Have you open up your presentation and take it from here.
Great. Can you see my slides?
Yeah.
Okay. Well, thank you, Tim, for the introduction. And as Secretary Nag pointed out astutely, we have a great collaboration across the state, stakeholders, farmers, extension, the DNR, Usgs, the Midwest Climatehub with Dr. Dennis Toddy. We're in a very good position of sharing information with each other and getting the best information to our stakeholders across the state. So we just benefit greatly in terms of what we do in our specific niches in terms of weather and climate and how they impact agriculture across the state. So I couldn't be happier to be in this great collaboration. So what I'll talk about briefly today will be the 2021 winter summary, and then some precipitation climatology as we get into the growing season. And of course, the main subject of this presentation and of this webinar, current drought conditions across the state. And as Tim noted, I am the state climatologist of Iowa with the Iowa Department of Agriculture and Land Stewardship. So briefly, we'll talk about the 2020 Climatological Summary because it has a very big impact on where we are today, given our current drought conditions. We started seeing dryness creeping in to the state in southwestern Iowa. Pottawatomie County was a kind of a bullseye, given the extreme wetness that we had and the flooding that we had in 2019, as Secretary Nag pointed out. We went in the fall of 2019, we started seeing precipitation deficits begin to form, and those were moving into the growing season last year. Now, of course, we had an excellent growing window, but then we started getting dry, and we'll kind of talk about that. Then I'll look at current conditions, what we see across the state, temperature-wise, precipitation-wise, the snowpack, the snow water equivalent in that snowpack, and various other indicators that give us an idea of where we're moving as we get into the growing season. And finally, we'll look at the drought, where we are, where we're moving, and the possibilities as such. And Dr. Toddy will get into the outlooks later. So first, let's look at the 2020 final climatological summary. Statewide temperatures averaged about 49 degrees, and that's about 1 degree below normal, and are one degree above normal, which ties multiple years as the 33rd warmest year on record. Now, if we do a month by month average of all our average temperatures for the 2020 or any year in general, Basically, those temperatures usually are in 1 to 2 degree range up or below what we expect climatologically. Where we do see a lot of variation and more variation as we move forward is in the statewide average precipitation. Now, 2018 was the second wettest year on record. 2019 was the 12th wettest year on record. You put those 2 years together, the wettest 2 calendar years going back 149 years. So we come off a wet stretch, and we had a drier than normal year, 36th driest year on record, and we were about 6 inches below average. Now, what this betrays are certain parts of the state saw above average precipitation, namely northeastern Iowa. And then if you split the state in half and had along I-80, or I-35, I should say, and go to western Iowa, very dry conditions, precipitation deficits on the order of anywhere from 12 to 18 inches below average. Now, at the end of the year, if you look over where this red box is, this is my a section of my monthly report that I put out on the website and through social media. You can see within those 9 climate divisions that we have across the state, we had precipitation departures, negative departures across a lot of those reporting districts, anywhere from 9 up to 12 inches below average. So coming into 2021, we were dry. Now, as Secretary Neg mentioned, at the beginning of 2020, the soil profile was locked and loaded. It was near capacity. We were ready to go start field work and getting planted. And then we started to get dry starting mid-May into mid-June. Now, if we look at the 2020 annual average precipitation for the state of Iowa, the warmer the colors here in western Iowa, if you can't see the boundary, is right in the middle of the plot. The warmer those colors, the higher the precipitation deficits. So you can see that core of red where the initial D3 drought region started popping up in July and August, and then kind of some semblance of drier conditions up in that northwestern corner where the current D3 drought region is. If you look at those cooler colors, we only see above average precipitation totals in northeastern Iowa. And let me define precipitation as anything liquid or frozen that falls out of the sky water-wise. We melt snow, sleet, and then add those to the liquid, and that is what we define as precipitation. So there's a tale of 2 states here if we look on our western border versus our eastern border. The browner those colors, or the darker those browns, the drier the year that those climate divisions have. And to situate you here, the northwest corner is Climate Division 1, and the southeast corner is Climate Division 9. So west to east and down, north to south, are climate divisions. The climate divisions 1, 5, and 7 were 9th, 9th, and 8th driest going back to 1895. So top 10 dry years in those 3 climate divisions. As we move further east, we start to get into wetter or near normal conditions. But that does tell the tale of where the drought region currently is and where we started to see dry conditions popping up last year. Just a basic winter 2020-2021 summary. And these are still preliminary with the asterisk there because we're still quality controlling the February 2021 data. But the remarkable thing about temperature-wise, if we look at December, January, and February, December and January were actually about 4 degrees, a little over 4 degrees above average in both of those months. And then we get into the Arctic outbreak in February, we were 12 degrees below average. So this is looking like it will be the 4th or the 5th coldest February on record. Now, if we take all those meteorological winter months and put them together, we were about 1.1 degrees below average. And that was basically because of February being so cold. Precipitation wise, we were right around average, though below average. And I'll show you a spatial plot of that. The first plot I'll show you is the temperature departure. So wherever you see green on there, that's where we had below average temperatures for the winter months. Wherever you see gray, that's where we were near average. So getting up into northern Iowa. And then just that northwestern corner, we saw slightly above average temperature totals, or temperatures. If we look at precipitation departures, so again, snow, rain, freezing rain, sleet, generally near average across the state, wherever you see that green color, up to 2 inches of above average precipitation. Wherever you see yellow, up to 2 inches below average. When you put them together, we're right near average. And that's kind of what happens when you see this bipolar behavior. Snowfall wise, snowfall is the big caveat here. This is again a departure plot. Wherever you see those greens and those blues, that's where we're getting anywhere from 15 to 25, even to 30 inches above average. Now, what we need to point out though is that the depth of the snowpack does not translate one-to-one into the snow water equivalent, and I'll get into that later. So now what we'll look at are the current conditions across the state, where we are, snowpack and snowmelt, precipitation deficits in general over the last 30 days, and then subsoil moisture, given that we have pretty dry percentiles in western Iowa. If we look at the 30-day temps, this goes back to the beginning of February, very, very cold temperatures. On the left-hand plot there, that's the actual average temperature. If you look at the right plot, that is the departure from the 30-year climatology. So the average, or what we expect. What you can see here is anywhere from 9 to 15 degrees below average over the last 30 days. And basically that came during the first half of February. Now we're in a warm up. Typically we see a swing like that when we do get into very anomalous behavior. And that's what we're seeing as we move forward and as Dr. Toddy will show. 30-day precipitation on the left-hand plot here. This is the actual precipitation that we've seen across the state. So basically up to 2 inches that we've seen over the last 30 days. If we look at the top plot here on the right, that is the departure from normal precipitation in inches. So wherever you see gray, that's basically we're near average with slight departures. A little corner of southwestern Iowa, slightly above average, and then down into the Iowa-Missouri border, slightly drier conditions are starting to creep in. Now, if we look at the percent of normal precipitation, we're kind of getting the same story. We've had some above average precipitation in western Iowa, but then basically dry across the rest of the state. Now, another caveat here is wintertime is the driest season of the month or of the year, with January being the driest, flanked by December and February. So it doesn't take a lot to get above or below average. Now we're starting to ramp up as we get into springtime, March, April, and then we get into May and June, which are the 2 wettest months for the state of Iowa. So we would expect climatologically an increase in the amount of precipitation, basically rainfall, as we get into the growing season and the warmer part of the year. Now, if we look at 6-month departure of precipitation, we do see a wetter stretch across eastern Iowa, and that's where we've had a more active storm track. This storm track has been pretty consistent in fall and winter in that it's been locked over the basically southeastern half of the state. So that's where we've seen precipitation surpluses stack up. And then we look across the state into the driest part, in northwestern Iowa, anywhere from 6 to 8 inches below average. So that is, again, our problem child in terms of the drought depiction. Now let's talk about snow depth and snowpack. From here, this is February 24th, the height of the snowpack after the extreme cold air outbreak that we had. Basically anywhere across eastern Iowa, anywhere from 6 to 12, locally up to 18 inches of existing snowpack on the ground. Now remember, the soil below this is insulated by the snowpack, so we don't get as cold and we don't get as deep of frost level as we have in western Iowa, and I'll show those pictures later. Drier soils dry faster, but they'll also dry deeper, so we'll have a deeper soil frozen profile. Also, the topsoil is frozen with a lack of or a diminished snowpack. So you don't get a lot of infiltration when you start to melt that snowpack. The second plot, again, is from February 24th. This is the snow water equivalent, or if you melted that entire snowpack, how much liquid water would you get out of it? Now, coming from a 12 to 18 inch snowpack and melting that down, it's deceiving given the depth of the snowpack. Basically, snow water equivalent in that snowpack is anywhere from 2 to 4 inches of liquid water. So again, you have a lot of runoff where you have frozen soils. You don't get a deep infiltration, even in warmer soils, especially in Western Iowa. So that is where we get into the discrepancy between, oh, well, there's a lot of snow out there that's ready to melt, not a lot of liquid water available within that snowpack, unfortunately. So that is one thing that we take into account. If we move to today, you notice that snowpack substantially has melted from Western and Southern Iowa. We're going to get into the 50s and 60s. We should expect the northeastern snowpack to really start to diminish. Luckily, we've had, in terms of flooding, the 40-20 rule, in which we've had highs basically in the 40s, overnight lows below freezing. So we've had a gentle melt and refreeze cycle. And my friend Jeff Zog will go over that during his part of the presentation. But again, we have an existing snowpack. Again, that snow water equivalent within that snowpack, anywhere from 2 to 4 inches. Not a lot of help for Western Iowa. Eastern Iowa is doing better in terms of subsoil profiles, subsoil moisture profiles. But again, not a lot of help out there. If we look at 4-inch soil temperatures, and this is from the Iowa Environmental Mesonet, we're getting into the upper 30s and low 40s across southern Iowa with the absence of that snowpack and our warmer than average temperatures. And where you see that snowpack still existent is in northeastern Iowa, hence the near or below freezing temperatures. So we're gradually warming up. The plot on the right was May 2nd. Plot on the left is March. I wish it were May, but we're getting into March. So we are seeing a gradual warming within that 4-inch soil profile. If we look at the frost depth, we have basically no frost in southern Iowa, given this red polygon down here. Then you look over into the northeastern snowpack, snow depths below a foot, so down to 17 inches, up to 12 inches across northwestern Iowa. But again, melting snowpack, we're starting to warm up that subsoil profile and starting to thaw out some of that frost. Now, if the outlooks do pan out and we do get into a wetter period, given the warmer temperatures that we're seeing, there is an ability for infiltration into that subsoil profile, especially in northwestern Iowa. So any moisture would help, but when you have soil profile deficits and precipitation deficits of 12 to 16 inches locally higher, we're gonna need timely rainfalls repeatedly getting into the growing season to help chip away at those deficits and at the drought conditions.
Hey, Justin, can I add real briefly? Can you go back to the previous one? There are some additional sensors from Iowa State stations, soil moisture and soil temperature up in northwest Iowa, that do give. They're down below 2 feet still at frozen. They're it's marginally frozen. It's not really hard, but we've got a little bit of time to go before we get infiltration there yet. So thanks.
But getting into that, the dry soils freeze faster. I don't think the soils froze as deep as we thought they could. So that was one, given the snowpack that we had on the ground. Now, if we get into the modeled or the remote sense subsoil moisture profile, this goes down to 200 centimeters or about 80 inches. Wherever you see warmer colors on this map, that's where we're below average percentile wise. So if we use a sponge as an example, and 100% would be full capacity, wherever you see the yellows to beige colors, that's where we're at the 30th to 20th percentile, or 70% capacity within that subsoil moisture profile. So lots of room to add soil moisture into this profile. And this really reflects the deficits that we have and the current drought depiction across western Iowa. Now, if we look at topsoil, so the very top 10 centimeters, wherever you see those colder colors, that's where we've actually seen an increase in the amount of topsoil moisture. And this is a result of snowpack melting in that top part of the soil profile actually are thawing out. So we've noticed lots of squishy soils out there, lots of puddles out there. What we'll see as we move forward, is those puddles, as the subsoil starts to thaw, those puddles will start to infiltrate as deep as they can. But again, as Dennis mentioned, not as deep as we would like them to be given the depth of the frost level. Now, if we look at a 3-month difference, this is a delta plot in terms of relative soil moisture percentage. We have seen an increase across the state, but again, not enough to put a dent. And then you recognize that the subsoil profile is frozen as well, and you have snowpack on top. So we would like to see additional movement towards these colder colors. So that will really hinge on our outlooks. Now, finally, let's look at the current drought depiction. As of from last week, and let me explain this map, it's released at 8 a.m. on Thursday, and it's backdated to the previous Tuesday. That's data cutoff at 8 a.m. So when Dennis and I and our Iowa experts are working on our recommendation to the U.S. Drought Monitor, we have to cut off all moisture variables on Tuesday morning. So that gives us some time for analysis. It gives some time for the U.S. Drought Monitor author for that 2-week cycle to actually start their due diligence on this. So status quo since last week, with again that D3 extreme drought region still in existence across northwestern Iowa. Now we're in a current balancing act here. We have seen short-term improvement, and short-term we define as basically less than 6 months versus longer-term precipitation deficits going back 12 months, 16 months, even back 18 months. Again, I mentioned the precipitation deficits that we see, especially across western Iowa, but in that west central Iowa corridor and then northwestern Iowa, where we had 2 D3 regions, precipitation deficits 12 to 18 inches below average. We're balancing those out. We have seen improvement over the past few weeks, but not exceptional improvement given all the factors that are in play, subsoil moisture profiles, the dryness of the soils, but also the frost depth. In terms of the drought categories, and this is a whole other webinar that we can do, the categories are basically based on historical percentiles, and I won't get in too in depth here, but when we're looking at that D0 or abnormally dry criterion, that's not drought, but it's abnormally dry conditions. Those are where kind of a sentinel for us to keep and be aware of as we go through the drought monitor process. But we would expect that once every 3 to 5 years for a specific location across the state. And then we get down into exceptional drought, which we haven't seen since the 2011 to 2013 widespread and pretty extreme drought across much of the Midwest. We would expect that D4 category once every more than 50 years. So where we have that D3 category in northwestern Iowa, those conditions on a broader scale haven't been apparent in the last 20 to 50 years. Now, of course, there's wiggle room when we get into where those categories should be drawn, and that's another webinar. But what we like to see in the moisture variables and all the variables that we use for the drought recommendation is a convergence of those evidence. So all of those, or a majority of those variables that we look at, stream flows, precipitation deficits, other indices for moisture, basically for drought, we want to see those all pointing in one direction. Well, it's not always apparent that they're pointing in one direction, and hence the current balancing act of where we see improvement or where we don't see rapid degradation. So here is the 2021 Iowa drought time series. The vertical axis, or the y-axis here, is the percent of the state covered in D0 to D3 conditions. And the x-axis, or that bottom axis there, is the timestamp. So basically since March or May, we started to see dry conditions start to creep into west central Iowa, given that D0 category. And then we really ramped up in July and August when D3 was introduced in west central Iowa. I had done a lot of field scouting with my extension friend, Megan Anderson, and we really did see moisture stress starting to creep in. So those are the type of impacts that we like to see in terms of getting the best recommendation to the drought monitor author. As you can see, drought is been pretty consistent across the state, but where it's been consistent is in northwestern Iowa, Climate Division 1. And that's where we see a higher coverage going from May, and then a larger portion of that in D1 through D3. So we've been, what this time series is showing us is we've been pretty much status quo in terms of the drought coverage and the severity of the drought since last spring. If we look at a 1-year class change, when you see green on this map, that means we've seen improvement in drought conditions. No green on this map. We've only seen a degradation in the dryness across much of the upper Midwest and the north central region of the United States. Where we see the most extreme conditions are in, of course, northwestern Iowa, and then getting down into Kansas and Nebraska. If we look at a change map for Iowa over the past month, I did mention we have seen improvement. Western Iowa, we've seen about a 1-class improvement from the main category of D1 down to, or upgraded to D0, or abnormally dry conditions. Now, the caveat here is if we continue to be dry, or we get into a dry regime, or we're not picking up what we would expect precipitation wise, we can easily get these regions back. So that's something always to keep in the back of our mind. One final plot here, expected precipitation. This is the 30-year climatology, 1981 to 2010, from April 1st to July 31st, wettest part of the year for Iowa. We would expect anywhere from 14 to 19 inches across the state of precipitation, basically rainfall. Row crops require a lot of that moisture, and given the dryness of the subsoil profile, especially in western Iowa, that's when we start to think about what ifs. What is the La Nina signal going to tell us? What if we transition into a different phase of El Nino Southern Oscillation? What if we get wetter than average? So those are the things that are always rolling around in a meteorologist or a climatologist's head. So more to come on this. Finally, our drought issues will continue. Very dry soils, especially in western Iowa. Again, frozen soils pretty deep in northwestern Iowa. And we are having ongoing discussions with the U.S. Drought Monitor authors in terms of where those improvements should be, where degradation should be, or if we should remain status quo as we move into a warmer and wetter part of the year. 2020 started off with ample subsoil moisture from very wet stretches of years, 2018 and 2019. Now, we get a lot of comparisons to 2012. It's very hard to compare drought years. We always remember the last large-scale drought. 2012 was the last large-scale drought, but it was very different in terms of its setup and its longevity. So we have to be careful. It's an apples to oranges comparison. So always be careful when you hear about those on social media or in the news. Soil profiles in eastern Iowa are in better shape. And as we melt more of that snowpack and get warmer, we should see those conditions remain pretty good. Finally, I mentioned the drought is not clear cut, so make sure you recognize those comparisons. Finally, here are my contact information, tidbits, email, and office phone. Please give me a call. I'm always happy to chat.
Thanks, Justin. I appreciate that. Good information as always. One thing I will point out to folks who are in the webinar is every month there's a collaborative document that we put together, Justin and myself and others who are on the presenter panel today, that we call the Water Summary Update. We've been putting that out for almost 10 years now. And every once a month we put that out to summarize precipitation, hydrology, groundwater. You can look for that next Thursday. It'll be in our Eco News and on the DNR website. So another place you can go for similar type of information. Again, just a reminder to folks on the call that, okay, put the contact information in the Q&A. Justin will get that on there. Yeah, if you have a question as we go through, just type it into Q&A and I'll get a notice that someone's asked a question and we'll respond to it as we go on. Okay, so we're going to move on in the agenda. The next up is John Nania with the USGS in Iowa City, the Central Midwest Water Science Center. We like to try to move through precipitation and then see how that shows up in stream flow and then see how that shows up in groundwater. So there's a quasi-logical approach to how we order the discussion. So John, I'm going to turn it over to you and go ahead and take over, and we'll look forward to hearing from you.
Sounds good. Thanks, Tim. Can you see my screen?
Absolutely. Yep, you're good.
Fantastic. Okay. Okay, so as Tim said, I'm John Nania. I'm with the USGS in Iowa City. And what Justin said actually was a great lead into what I'm going to be talking about for stream flow conditions. Kind of tells us how we got to where we are today with stream flow conditions. So I'm going to show you our current stream flow conditions, as well as making some comparisons to where we have been with stream flows at previous droughts, to kind of show you, give you a little bit of a comparison there. And just to lead into it, so we've got about 200 locations across the state where we monitor the streams, and about 120 or so have stream flows associated, meaning that volume of water that's flowing down the river at any given time. We usually describe it in cubic feet per second, but many people use gallons per day or whatever is most useful to you. And those stream flow values are important for many reasons, for flood forecasting purposes with the National Weather Service, managing the reservoirs like Saylorville for the Corps, irrigation, when we get down to lower flows, various water quality implications, just on and on, groundwater recharge, that sort of thing. So on this map, you'll see you'll see locations where we have stream flows with 30 years of data or more. Those are the ones that have colors on them, and that is starting to show you how current stream flows compare to historic stream flows at that same time. So greener colors mean it's kind of in that normal range for that same time. Blues are wetter or higher, and the reds are lower. Reds and oranges are lower. Now, this map here, I know it's showing from December 9th, but that was right before ice started coming on the rivers. And if I look at yesterday's stream flows, you'll see a lot of those colors are taken off. That's because ice causes some uncertainty for us in the stream flow calculations, and we go back and recompute those, but it's a little, we have less confidence in showing them in real time and showing those colors, so we take those off during ice conditions. So I just wanted to give you an example back in December and then show you kind of what we're seeing now. But we can still we can still compute flows at those sites, and the way we do that in the winter is we still go out and make routine measurements at sites. You just have to cut holes in the ice, so the waters are still, the rivers are still flowing, but then we can still use those values to back compute and get our values for stream flow, so we can make fill those records in when we need to. So, but we still have enough information that we can start to make some assumptions statewide on where we are with current stream flows. So we can still show you where we were yesterday with stream flows, and this is a snapshot, like I said, from yesterday, where much of the state is showing in that normal range. Again, this is for every March 3rd in history, basically, where we were compared to every March 3rd in history. And I'll have an image later on where kind of show at a few sites where that normal range, that green range, kind of fluctuates throughout the year. You know, normal might mean something different in April, May. So, but just to highlight yesterday what we were seeing. So we're seeing above normal flows in the Skunk River Basin and then over in the Wapsie. But we're still seeing some lower flows in the upper Des Moines, in the middle Des Moines area there. So even though that we're getting some snow melt, and they're still showing some lower flows in that Des Moines area, that middle Des Moines River area there. So we can then take this and look if we want to see regionally or nationally how our flows are comparing, if we have some interests or some just to see how things are looking regionally and nationally. We can take that and look at a bigger scale. But for us, for the purpose of this call, it might be more important to kind of look to see how we compare to historic flows. And even just looking back into December, just about 3 months ago, 4 months ago, we can see that we were going into the winter with some low flow conditions in the Raccoon, the Des Moines, and then the lower Des Moines as well, and then the middle Skunk. So we were seeing much below normal flows in the lower Des Moines right before going into the winter conditions. So, and as Justin was showing on his drought, we started to see this map being basically green statewide in May-ish, June, and then as Justin showed, we were getting drought conditions creep in, and these orange and reds were creeping in slowly throughout the months, and then but this is kind of what we were seeing throughout the last 3-4 months of the calendar year is what you're seeing here on the left side of the screen, where the Raccoon, the Skunk, and Des Moines rivers were much below. So okay, and then just going back about a year, just 1 year from now, 1 year ago is when we were coming in from that wet 2019, and we had some flows in the much above normal conditions. So it was somewhat fortunate that we had that because of the low precipitation, and I kind of was able to keep the river conditions up as we went throughout the year. So no telling kind of where they would have been without those higher stream flow conditions coming out of the winter from 2019. Okay, then starting to compare back to some drought conditions. So if we were to look back at early March of 2012, we saw some similar conditions, although in Northwest Iowa we were actually a little wetter. Higher stream flow conditions back in 2012 as compared to now. So we went into the spring with some above normal flow conditions in Northwest Iowa at this time back in 2012. So, but then looking at the height of the drought, or near some of the height of the drought back in 2012. On the left side of the screen there, you'll see we were pretty much below normal statewide, or to much below normal statewide. So that's how the stream flow conditions progressed throughout the year in 2012. And then just one other drought of notice to mention was 1977 back in January, where we had extreme low flow conditions basically statewide. 1977 for those of us that may ever reference that time period, but just one other drought condition to compare to. So I just wanted to highlight a few sites, just zoom in on a couple of sites across the state here. I'm actually look at a couple of lakes too, because those are good indicators of drought conditions as well. And there's a lot going on here, but this is kind of where I show how the stream flow conditions, what normal is, how it changes throughout the year. So I'm picking Boone River near Webster City, so kind of getting to Northwest Iowa, and pick that site because that's one of our sites where we hit pretty heavy during the winter. We have a handful of sites across the state where we go out once to twice a week to make stream flow measurements and use that to make some assumptions in the region that those are in because of that variable ice conditions that I was talking about earlier. So we have up-to-date confident data here that I could show you. On the right side is our current conditions. So right now at Webster City on the Boone River, we're into the normal range, although we were down pretty before the snow started to melt and get some runoff. We were really down into the really much below normal category. So we're just creeping into the normal category now, but you can see how just throughout the year where normal changes with the stream flow CFS cubic feet per second on the left here. You can see how much it might change throughout the year. So that normal does change. So as compared to 2012, showed on the left here, back in March, we were actually pretty similar, just creeping back up, very similar pattern, creeping back up into the normal condition, and then we're a dip back down soon after that. So that's Webster City, the Moon River at Webster City, comparing it back to 2012, and just as a quick comparison back to 1977, where we had record stream flows, where the river was essentially dry, and then it basically stayed very low until later that year, and in July, August. So just a quick comparison there. And then one more comparison where we have confidence in our data up through yesterday. Missouri River near Sioux City. No, it's a regulated stream through Gavins up there, but we're showing normal flows here right now at Sioux City on the Missouri River. Basically has been staying in that normal range as much as possible, but acts a little different as it's a regulated stream. And then comparing it back to 2012, the Missouri was driven differently. So much of 2012, it stayed in that normal range, which coming out of 2011, you can see the 2011 floods here, which were the record floods back on the Missouri River. So we all remember those well. So okay, so and then comparing Missouri River back to 1977, again, same thing, regulated stream. So pretty much can keep that in the normal range as long as what's going on in the upper limits of the basin can continue to support that. Okay, and then just a couple lake levels I want to point out here before I wrap up. So I'm showing West Okoboji Lake and then Clear Lake here, which is on the right, from 1970 to current, so quite a long time period here. But you can see, let's start with West Okoboji Lake. Our current level is shown here towards the right side of the graph, and how that compares with previous times in history back to 1970. So again, that 1977 drought was only a foot, I should say, not should say only, but it was a foot lower, which may not seem like a lot, a little over a foot lower, but it in terms of the lake level, that is quite a bit lower at West Okoboji Lake. And then back in the 80s as well, we had some low flows too. But in 2012, it didn't drop quite as low as it did to those other historic droughts. But so we're sitting above those levels currently still, but just time will tell to see how that pans out. And then Clear Lake, we're still sitting quite a bit above where we have been at some historic droughts, like in 2012 and in the late 80s, and in 1977 as well. So just wanted to point out a couple of lakes as an example to kind of where we're standing with surface water conditions. And then just wanted to highlight a couple tools which will be shared. Don't expect anyone to write these down because anticipate these being shared, what Tim mentioned earlier. So a couple of links here where I've been pulling the information, same information that anyone else could retrieve, is the USGS National Water Dashboard, where you can see real-time stream flow levels, works well on a mobile device, and then the USGS Water Watch shown here on the lower right. One other thing to point out here is this USGS Water Alert tool. So those of you that may have interest in particular locations of stream flows or stream gauges that we have, you can set up a threshold. Like even if the water level were to dip below a certain level, it could send you a text message or an email. Like for example, I just got one earlier this week for Willow Creek near Soldier, because that's a site of interest to me and for a special project, and I wanted to know when it crossed a certain level, so I got an email, but you could easily get a text message. So it's a very simple thing to subscribe to on any of our websites where you see a USGS a gauge. You can always, there's like usually a subscribe button that you can click to these. So very useful. And just our most popular one happens to be West Okoboji Lake for water temperature, believe it or not. When water temperature changes, we've got quite a few subscribers signed up for water alerts for Okoboji Lake, but got many users across the state for our streams as well. But a very useful tool if you need to be notified when certain conditions are crossed. So, with that, I'll just wrap it up. Just to summarize where we stand statewide in pretty much normal conditions or above normal conditions, except for that area on the middle Des Moines River. And just kind of time will tell on how that pans out, if that'll stay normal or drop normal, especially in the northwest part of the state. We're still seeing ice conditions across the state, so we're still monitoring those as the ice goes out. So, and with that, I will turn it back over to Tim.
Thanks, John. Appreciate that. Good information. As John mentioned, much of this information that he showed us today is available to anybody through the USGS's any number of their websites. So the information that you'll be able to get, his presentation and the links and the emails, if anything is of interest to you, you can pretty much go and get it. And if you have trouble finding it, John and his staff would be happy to get you steered in the right direction. So if that's something of interest to you, check out the notes that'll be available early next week, and you can go to the website and you can get that information on your own. So appreciate that, John. Next up, we're going to talk about groundwater a little bit. Chad Fields was originally going to be presenting information, but he got tied up in something else. So Michael Anderson, one of our Water Quality Bureau folks and engineers over there, is going to provide information on groundwater conditions. So I'm going to turn this over to Michael Anderson, and he'll provide the information. And again, if you have questions, as a couple of folks have already, throw them in the queue and type them in the Q&A box, and we'll be happy to respond as we go through or at the end. So Michael, take it away. Pull yourself off mute, Michael. There you go, and I can see your stuff just fine. Nope, you're back on mute.
Looks like Megan rescued me. Good afternoon, everyone. Thanks for your patience. This will be a fairly brief overview of some groundwater conditions specific to some of the areas we're just a little bit worried about. As Tim mentioned, I'm kind of pinch hitting for Chad Fields, one of the geologists I work closely with in water allocation. I'm the senior engineer in water allocation, and we'll be talking a little bit just about some of our permitted entities and things we're watching. Let's see, advance. Oops, there we go. One of our index gauges that's very close to the area we're concerned in, it's kind of down on the very bottom of the really dry northwest part of the area, is in Crawford County, and it's a cooperative long-term monitoring of groundwater levels that we do with the USGS. It's a shallow alluvial well, 48 feet below the land surface, in Pleistocene area of really could almost be considered alluvial. It's a Crawford County well. And we're going to take a quick look at long-term water levels as we've been watching it, taking a time series graph from 2012 and showing behavior in the last significant drought, 2011 up through 2013, and then some degree of recovery into 2014. Now, if we're sitting right about the time series now, right at the start of the turnover of the year, we're seeing a longer term trend towards lower water levels. A specific indication in Crawford County, but one we've followed very closely over the years. One of the things we monitor in our program real closely is the amount of water that is utilized both by irrigators and by municipal and rural water systems. And what we put together here is an aggregate graph of how much water has been utilized by alluvial rural water districts. Again, we're focusing very much on the northwest part of the state. You see some specific permits plotted here over on the right axis and a total cumulative amount of water used over the years. So you see some trends just in the last year or two downward. Hard to say exactly, some potential drop with possibly COVID, but a longer term trend over the last 10 years upward and putting some more pressure on our alluvial systems. As we move into this year, this is something we very closely monitor, both cumulative usage and then some specific systems. Now, we're not picking on any particular area, but I'm pointing out an area we closely monitor just as an example of some of the things we do and some of the things our partners get concerned about. We're looking at a rural area with some 20 plus agricultural irrigators. They're plotted in various, their well locations on this topo map. We see the Big Sioux River over on the western side, the Rock River kind of dominating the east side, and then the confluence just below here. You see a number of red marked wells as a particular rural water system and another one over here. Just nothing, again, nothing specific about that other than this is in Sioux County, which is one of the identified D3 areas. So one we just want to keep an eye on, especially as we move into the next couple of months. And this time series graph, which is about the last graph I'm going to share, is just showing some of the accumulated irrigation permits and give an idea of the pressure as we get into the irrigation season that can happen. We got 11, we've got 2012, and so on, 2015, 2017, 2020. Not a pronounced increase over time, but again, showing generalized agricultural irrigation pressure. And now keep in mind, all this is considered in our rural estimation. This is all beneficial use. This is all good use of water for crop growing. It just shows in an area, and I'm going to jump back to my previous slide. It just shows that there's pressure on an area. And in a normal year, while we would collect the data on the area, we wouldn't pay that much attention to it. In a year like last year, and especially as we move into this year, it's something we very, very closely monitor because there is both the potential for competing uses and then the potential for dropping water levels as the growing season begins and the hotter temperatures come in. And it's an area we paid a lot of attention to in 2011 and especially 2012. And especially a lot of you will remember one of the things that's, I wouldn't call it a totally worst case scenario, but a scenario that certainly worries us was a stretch of weather in July and especially August where there were 140, even 108, 109 degree Fahrenheit days. And there's some classic graphs on the way evaporation increases and stress in water and water usage increases when that happens. With that, I'll just summarize as saying it's a concern. We're keeping an eye on things. All of our partners are keeping an eye on things. As Justin touched on and Dennis will be touching on, we're really paying attention to the overall precip and again, the percentage that's going into soil moisture. We have some index graphs. I just gave you a few gauges that I think are good examples of what we monitor. And for that, I think we'll just say we'll keep an eye on things. Like the other presentations, this will be available and so will be my contact information if anyone has really new low groundwater levels and things as the year moves in, we want to hear about it, and we want to hear about it just as soon as we can. Okay.
Thanks, Michael. Just a couple of things I wanted to point out. There's an emphasis or a focus on Northwest Iowa, not just because it's where we're seeing prevalent drought conditions right now, but it's also because that's the area of the state where hydrogeologically there are not a lot of groundwater options beyond shallow alluvial aquifers. Unlike eastern Iowa, where you can drill down and get into some fairly prolific aquifers farther down, that really isn't an option in much of Northwest Iowa. And the other thing I wanted to point out, which is the reason why this becomes a real challenge, the groundwater side is, as John Nania mentioned, they go out and monitor stream flow. Well, in theory, you could drive to any bridge and make an observation or a measurement of stream flow. In groundwater, obviously it's hidden, it's down under the ground, you have to have a well to go find it. It's just harder to get access to that information. So as the growing season unfolds, we rely on information that's reported to us from rural water systems and other wells. It just makes the process of reporting the groundwater conditions a little bit more challenging for us. So anyway, Michael, thank you for that. And as Michael indicated, that information will be available next week. And if you have questions, you can reach out to Michael or to Chad Fields, and they'll be happy to help you with that. We're going to move to our next presenter. This is something that we added this go around that we didn't have back in January. I've asked Jeff Zog from the National Weather Service. He's a senior service hydrologist with the National Weather Service here in Johnston to talk a little bit about the flood outlooks. It might seem odd to combine flood outlooks with drought, but they're really a representation of the hydrology of the state. So it's a good way to see kind of how we're looking. And we also have Mike Gillespie, who's Jeff's counterpart in the Sioux Falls office, if we have questions about conditions particular to Northwest Iowa. So Jeff, I'm going to turn it over to you, and we'll go from there.
Okay, thank you, Tim. Let me get my screen shared. See, can you see my PowerPoint?
Yep, just fine.
Okay, awesome. Okay, I'm going to go to a full screen mode here. There we go. As the presentations have been going along, I've been actually hiding some of my slides. I'm not going to show them all because they'd be redundant, because some of my slides talked about things like stream flow and snowpack and precipitation departures and so on. So my presentation will be probably a lot shorter than it otherwise would have been, which is probably fine with a lot of people. But this was the outlook number 2 that we issued basically a week ago. We're kind of in between outlooks right now, so I'll kind of interject some thoughts as we go along, because things have changed a little bit here. But we'll go ahead and jump into the outlooks. And again, as of February 22nd, this was the spring flood outlook we were looking for. Kind of a varied bag across the state. For the Mississippi River above the Rock River, which is roughly the Quad Cities, the near normal flood risk, below the Rock River and above normal risk. The Missouri River.
Jeff, I'm still seeing your opening slide.
You are. Can you see the spring flood outlook slide?
On the left-hand side. I'm not seeing full screen mode here. I'm just seeing there. I can see it now.
Okay. Well, what I'll do, just in the interest of time, is I'll try to make this a little bit bigger. And I'll just step through the slides one at a time.
That's fine.
Yeah.
Perfect. It looks good now.
Okay, thanks. But Mississippi River above the Quad Cities near normal risk of flooding, below the Rock River and above normal risk of flooding. The Missouri River near normal risk of flooding, what we were thinking back on the 22nd. The tributaries to the Mississippi River in Iowa, especially in eastern Iowa, and above normal risk. In the central part of the state, kind of near normal. And the tributaries to the Missouri River in Iowa, which is roughly the western third of the state, of below normal risk of flooding. And We should also point out that ice jams are also a risk to flooding, just with the cold weather we had, especially in February. We had an opportunity for the ice to grow relatively thick on the rivers. So as that ice breaks up, especially if we get a lot of rainfall in a short period of time or more snow and it melts rapidly, it could break up that ice, maybe cause some localized flooding. And anymore, we have to look forward. The amount, the frequency, and the extent of future precipitation, especially that rainfall, if we warm up, will be very important in determining the risk of flooding. So as far as the outlook schedule, what we're seeing right now is we had the first one on February 11th, the second one on February 25th, and the third one will be next week. So as I said before, we're kind of in between outlooks. We'll do my best to kind of interject thoughts as we go along here. So I did want to show, we kind of showed this slide before, but the soil moisture percentile slide, we can see it across the western part of the state. In that graphic on the upper left, the percentiles are showing below normal soil moisture and near normal across the rest of the state. Not a lot of change, over the past week, which we tend to expect during the winter. Not a lot of change there. Now looking forward here, let me make this a little bit bigger here. For the month of March, in the upper left-hand corner, the temperature outlook is calling for above normal temperatures for March, and precipitation in the upper right, kind of a mixed bag across extreme eastern Iowa, above normal conditions, and then what we call equal chances across the rest of the state. And by equal chances, what we mean is there's no strong indication of above or below normal conditions. When we're making these outlooks, we look at various indicators, and they fall into various bins, maybe an above normal bin, a below normal bin, and so on. When we see equal chances, there's kind of an equal distribution of those indicators. So there's no strong indication. So we just say equal chances. For the 3-month outlook for March, April, May, in the lower left there for temperature, we can see above normal temperatures indicated. And then for precipitation, about the same thing, equal chances, above normal across the extreme eastern part of the state and equal chances across the rest of the state. One thing I should point out is that these outlooks that we issue, the 3 outlooks that we're issuing, do not take into account temperature or precip outlooks. They only look at the current conditions, and because we don't look at the outlooks with the simulations that we run, we assume climatology by definition, which is near normal. So if we are highly confident, for example, that the spring is going to be above normal in terms of precipitation, then the numbers that we see for the spring flood outlooks might be a little bit too low. But we're not seeing that strong indication of above normal right now, so we'll probably just stick with the numbers that we have. For the seasonal drought outlook, this was back in mid-February, but not a lot of change since then. We're expecting the drought to persist over about the next 3 months or so, which you would tend to expect this time of year. Not a lot of change is what's going on. It doesn't change a lot during the winter. So as far as the factors that we consider when we look at the spring flood outlook, again, the snowpack back in late February was still above normal, but we've lost a lot of the snowpack since then. So that increased risk is probably a little too pessimistic. It's probably neutral. We're sitting pretty good right now. We've had a nearly ideal snow melt, but of course, future precipitation, future snowfall may change that. All the rest of the factors, soil moisture, frost depth, stream flow, and stream levels, and the precipitation outlook, neutral conditions. So really no strong factors to cause us a lot of concern as far as the spring flood outlook. And so just again, reviewing, this is a repeat of the earlier slide that I showed, a mixed bag across the state. Up in northwest Iowa, where the tributaries exist to the Missouri River back in late February, that was a below normal risk. Probably looking at that again, not a lot of change. And again, we'll update the outlook next Thursday, and the Weather Service offices will put that on their web pages. And I will have an updated slide deck for Iowa on our webpage at weather.gov/Des Moines, along with the outlook for the National Weather Service Des Moines service area. But again, we want to stress to be on the lookout for ice jams. That can cause localized flooding, especially if you get a quick rainfall event with some runoff to break up that ice. So just be on the lookout for that. And we've alerted a lot of our emergency managers in the ice jam prone counties to be on the outlook for that. And again, the amount, the frequency, and the extent of future precipitation will be very important in determining that risk. You know, when the rains come, the distribution, how often they happen, how heavy they are, that can really determine the risk of flooding. But right now, overall across the state, we're sitting pretty good, but we'll continue monitoring that. And with that, that ends my presentation, and I'll share the PowerPoint with Tim. But that's the context that we have for the various National Weather Service offices across the state.
Thanks, Jeff. Hopefully we don't have to deal with drought and flooding at the same time, although it probably wouldn't be the first time. Appreciate that. As we continue to work through the agenda, there's one question out there that we'll get to here. But Dennis Toddy with the USDA Midwest Climate Hub, he works out of Ames on the Iowa State campus. Is going to talk about weather and climate outlooks. So as we mentioned the last time we did this seminar, Dennis has polished up his crystal ball and will tell us what lies ahead. So Dennis, it's all yours. And I can see your video or your presentation.
Thank you. Had to get myself unmuted here. So thanks, Tim. I appreciate it. Thanks to all the folks ahead of me, helping set the stage that we can see. Yeah, am I seeing the full slide? Or are we seeing the swapped version? Need to double check here real quick.
I'm seeing a split screen between the photo on one side and the Climate Hubs on the other.
Okay. All
That's
right.
better.
Okay. Got it now. Okay. All right. Okay. Because what we're going to talk about now is when we talk about the outlooks, we unfortunately can't give you a great idea of what's going to happen this summer. That's not to say weather forecasts aren't useful. They are useful. Near-term forecasts are very useful. But when we start looking ahead, that ability to tell you what's happening in the longer term becomes a bit more difficult the farther we go out in time. So that's why we focused a lot on current conditions, because that is the big emphasis on where we are now, to be able to move that ahead to looking ahead at the next step. So, all right, let's go ahead here. Just a reminder, we are part of USDA. We cover an 8-state region, a part of Iowa. But we help out with other issues in the state, because this is especially an agricultural issue that we're dealing with. And a rehash on where we are with the U.S. Drought Monitor, just to remind where we are, and be happy that we're not in the Southwest, where conditions are a lot worse. But in the lower right-hand side, we are on the edge of some more serious issues just to our west, giving us a little bit more concern. One more slide. Justin showed you the 1 month. This is the 2-month change in what has happened with the Drought Monitor, showing that Iowa, western, parts of central to western Iowa over into, let's get the laser pointer up here, central western Iowa over into Nebraska has improved slightly, where we've seen some worsening up in the Dakotas and up around the Great Lakes area. Okay, let's jump ahead to the outlooks now. What are the main points? The main points right now are spring is a time for some possible improvement. Okay, let's go ahead and swap back then. Okay, spring is a time for some possible improvement. Why is that? Because we get some additional precipitation compared to evaporation and plant use. We don't have anything actively growing, so it's not able to use much. We're not going to use much water in the soil. Evaporation, because temperatures aren't as high, we don't evaporate as much from the surface. So the rains we do get, especially once we get the soils thawed in northwest Iowa, north central Iowa are two critical areas. Southern Iowa, mostly, it looks like the frost is out of the ground. Then we can get water entering the soils. Okay, so that's one piece of information. The next one is La Nina, which is a somewhat of a controller, not the complete controller. We're talking about what's happening in the equatorial Pacific. does have some influence on what's happening near us. This is going to persist in the spring. So the outlooks that we show you have very much a La Nina flavor to them. About if you under an average La Nina, this is what happens. We're going to show that. We are still kind of in a boundary area. Jeff showed you the first of those. We're going to show you a couple more of those. We are kind of between some possible areas. So that does give us a little bit more of a mixed result as to what we can say. And then there's also this something that we won't go into a great detail about, but using computer models over longer time periods, there's this spring prediction barrier that the modelers talk about. Basically, there's when you forecast from late winter into summer, modelers have less confidence because there's a prediction barrier. Things can change from that transition from winter into spring. So let's go ahead here. Here's a reminder of what things look like in the way of climatology. This is for Ames, but everywhere in the state looks similar to this. Justin showed you like the average precipitation total over a time period. I believe it was something until July, May to July or something like that. Here's what this looks like month by month. The green bars are the average precipitation by month. We are starting to get into that time of year of the most precipitation. So May through August is the wettest time of the year. And this is that time where I mentioned we're seeing an increase in precipitation on average, okay? And then the temperatures gradually increase month by month. There's a lot of variability in there, but these are monthly averages. So we get increased precipitation before we get as much heat. So that's why we expect to, or we hope to get some help during the springtime. Okay, jumping through several steps of outlooks here. We have finally gotten past the cold. Relatively warm temperatures overall we're expecting for the next week or so. In the next 7 days, we are expecting some precipitation. Unfortunately, this area has shifted in some of the model runs. This is getting into the middle of next week, and it looks like eastern Iowa and east and north are the areas that expect more precipitation out of this. We could see some 1-inch precip amounts. Western Iowa has a chance, but more on the 1/4 to 1/2 inch, it looks like right now. Still a long time out. So this is not going to be a deal breaker or a deal maker, but there is a chance for some precipitation coming next week. Okay. Now, the next outlook is going to show you, I talked about how the further out we go, it's harder for us to be definitive about what's going to happen. So all the outlooks from here on are all based on probabilities. And these are increased probabilities that you are wetter or drier, or increased probabilities of warmer or colder. And we'll show you those as we come along. And these incorporate various pieces of science. They incorporate computer models, ocean effects like La Nina, and trends. They do include trends as part of this also. And we'll jump past this one and get right on to those. These Jeff showed already, a little closer view of them now. And all of these that we're going to show from here on, temperatures on the left-hand side, precipitation is on the right-hand side. This is the 8 to 14 day outlook. And as I say this is probably outdated because the new one just came out, comes out just after 2 every afternoon. Iowa again is in that boundary area, more likely warmer to our east, more likely colder to our west. This is getting in towards the 3rd week of March as we're going along here. It does look like the latter part of the month, there is a chance of turning a bit colder again after this nice warm stretch. The green area on the right shows we have a slightly increased chance of precipitation. This is not a big increase, but it's an indication that we could be a little bit more active in the pattern, which would be good. But again, it's not going to fix things at this point. Okay, now the seasonal outlook for March. This is what we can say for the month of March. Most of the eastern part of the country, the darker red areas here around the Great Lakes and some in the south have a fairly good chance of being warmer than average in March, colder out on the west coast. And then Iowa again is in this boundary area, more likely wetter to our east, more likely drier to our west. Again, very La Nina influenced. If you look at average La Ninas this time of year, you see something that looks like this. So the Great Lakes, Ohio Valley have a better chance. Their water issues are less at this point. They have a little bit of dryness, but that will probably be alleviated. That drought area in the plains is going to likely worsen and add to the warmth that's more likely as we showed here. So this is why we're be a little bit more concerned right now because of the dryness we have in the western part of the state, and we're not seeing indications of much improvement overall. Along with that, Jeff showed you the seasonal drought outlook. This is the monthly drought outlook, which basically says for the month of February, what is the expectation in the way of drought is going. The area that's in drought in western Iowa is likely to stay there. We don't see enough to move the needle too much. And the area that had been cleared in a little bit of western Iowa, eastern Nebraska, seems likely to come back, has a better chance of coming back given the overall dry conditions, the drier conditions that are more projected. Now we look a little bit further, March through May, but you don't see a lot of difference from what we saw for the month of March. Just some increased chances of dryness in the plains, including part of Iowa. This is not a big, strong indication of warmer than average, but we lean a little bit towards the warm side. And again, we're caught between the more likely wetter to our east, more likely drier to our west. But the little bit of dry area does hint on western Iowa. And this is where we focus on current conditions. If we saw this, and like last year, several people showed how wet we were coming into last year and saw a little bit of dryness, we'd be going, yeah, good thing for ag, good thing from a lot of standpoints. When we are dry coming in, and any hints of continued dryness gives us an additional concern and a little tick mark that we want to keep closer eye on things. And then we jump ahead May through July. May through July now, getting into the bigger part of the growing season. The whole US has a better chance of being warmer than average. This is not La Nina influenced right now as much as more trend overall, and some of the computer models. And then on the right-hand side, Iowa's EC equal chances, but again, close to that area that is more likely drier out to our west. Only slightly more likely. But again, when you've got dry conditions, any lean in the probabilities towards additional dryness is a problem. So ag and other interests out in the west are watching this very carefully because of grave concerns. And the reason we're talking about several of these things, I talked about La Nina. This plot just shows you what the probabilities of La Nina are in 3-month periods. So we are now in February, March, April, May. March, April, May, the highest probability of these 3 bars is La Nina. So we have a little over 60% chance of being in La Nina. Possibility we slip into neutral, but it's likely staying in La Nina. As we go through the middle part of summer, we are more likely to go between categories to be neutral. And that's why the outlooks through the summer will take on a different flavor because we don't have the La Nina influence. La Nina could stick around, but it seems less likely. And then as we get later in the year, there is an increasing chance La Nina returns. So it begins to be another thing we talk about going on. So this adds to the complexity of what we're talking about in the way of summer. If La Nina would hang around till the summer, we have an increased chance of being, slightly increased chance of being warmer based on June through August during La Nina, and a slightly increased chance of being drier. So it's not a guarantee, and it's not even a guarantee that we're going to stay in La Nina, but it's another factor that leads into this, a number of different pieces to the puzzle that indicate increased chances and problems as we're going along. Okay, take home messages. Still very dry. A lot of snow, had a little bit of improvement, still very dry, especially in our soils up in northwest Iowa. Some spring recovery is possible. We are very unlikely to fix things in the spring, but we have some spring recovery possible. Puts us at risk of these drought problems from starting from the year and continuing through the year. It's a very possible that we have some ongoing drought issues throughout the year. And then, as we look ahead further into the warm season, the growing season, with the current dry conditions, potential future problems, we could have those problems continue through the growing season. There's still a lot to be determined. There's still some things that we don't know, so we could improve, but the evidence indicates to ongoing potential issues that we need to watch very closely and to look ahead and make sure we're managing through. Okay. We mentioned this last time, but a reminder, on a monthly basis, we participate in a partnership of webinars where we talk very much like this situation, except on a broader scale. What we talk about, water, ag, a number of different issues from the plains to the Midwest. You get a good flavor of what's going on. The top link is where you go to sign up, or the shorter one down the bottom is the place where you can get that link. You can get to that same link below. This was the last time I presented. No, this was 2 years ago. Justin is a presenter about once a year along with me. And it's a good chance to get an update and ask questions on a regular basis. And Climatehub's website, and we'll go jump here to my Twitter information, our website, and contact information for me at the hub. So thanks, and I hope we have some questions and good conversation.
Good, Dennis, I appreciate that. Yeah, we try to leave enough time here at the end for questions and discussion about these topics. I just wanted to mention that the suggestion Dennis had about those monthly updates, if this is the kind of information which is of value and interest to you, hop onto those monthly presentations. They're an hour in length, and they're typically on a Thursday, and they're great opportunities to get a similar flavor across the Midwest, kind of from Kentucky, Indiana, all the way west to the Dakotas and Montana. It gives you a great overview of hydrology and climate across the Midwestern region on a once a month basis, and a chance to ask questions and get more information. So that will be helpful to you. I am going to do one thing. I have another poll that I want to just throw out there, and if you would be so kind to as to fill it out, it'll give us a chance to kind of gauge whether this information is useful, whether we need additional information. If the conditions continue to deteriorate, we'll have similar discussions like this, and hopefully this is useful to those of you who've hopped on the line. So I'm going to open up that poll, and then I'll have to find the second poll. There it is. So I'm going to launch the second poll, and I'll just let it run until it looks like most everybody who's interested in filling it out has filled it out. So Dennis, and or actually all the panelists, if you want to flip your video on, we can have questions like the one that was asked before. Dennis, there was one. Where did that go? Oh, can anyone fit shorter term trends into the larger view of climate change? Don't know if any of you, Dennis or Justin, want to tackle that question.
You want me to start, Justin, or you want to take a swing?
Go ahead. I can.
Okay. All right. The thing you have to remember is the various scales of weather and climate. Okay, there is a large amount of variability in our climate. There's natural variability that exists in addition to some of the additional climate change issues that we have imposed on it. And in one of those is wetter and drier periods. So we're always going to have wetter periods and drier periods as part of this, along with this longer term change that we are seeing. So drought is part of that. We don't ever want to lose track of that. It is interesting because the overall change we're seeing mostly in our region is wetter conditions. But inside those wetter conditions, we have dry periods, some of them very significant dry periods that we have to be ready to deal with.
Yeah, so if you look at the climate projections for the mid-latitudes and, well, let's say the Midwest, including Iowa, we're seeing, and the trends are showing us this over the last 30 years, and you can go back to 1895 as well. We've seen an increase in the atmospheric temperature, and by our Clausius-Clapeyron equation, which is our fancy, this much water vapor is held in the atmosphere given this temperature rise. So 1 degree Fahrenheit temperature rise is typically 4% more water vapor holding capacity in the atmosphere. We get more, or what we're seeing are higher intensity events more often on smaller scales, but also on wider scales. So if you connect these with the climate change projections that we see in the GCMs, or the global climate models, seasonally, we're seeing an increase in fall and winter, winter, and spring precipitation in terms of agriculture, right when field work starts, or right when we want to get planted, or right when we want to harvest. And then right in the middle, the GCM projections towards the end of the 21st century have the summertime conditions drying out. So not as much precipitation. Dennis mentioned we're wet from May through August. We're starting to see a signal in which that period of time is becoming drier, right around when the crop matures, right around when livestock need relief during the hottest part of the years. We're also seeing stringing hotter days together for a longer duration, so longer scale heat waves. You know, we always get this question when you get into Arctic outbreaks with the polar vortex, how can that be climate change if we're warming basically whole scale in the mid-latitudes? We're seeing our extremes become more extreme. Colders are becoming colder, warms are becoming warmer, and same thing with wet and dry. So we're seeing more aerial flooding, but we're also seeing more drought conditions and for a longer time scale.
Interesting. Yeah, I remember, Justin, your predecessor, Harry Hilliker, used to say weather has a way of being brutally average.
That's why it's easy to be a climatologist.
Let's see, here's a question from Larry Buss. Looking at wet, dry conditions that Dennis is talking about, what do you experts think about climate cycles? Specifically, do you believe in the 90-year cycle of major drought, which coming from the dry 30s would mean the 2020s would be generally dry and have a major drought? Any thoughts on that?
Yeah, I've got a few. The Gleisberg cycle, the 90-year cycle, we have solar cycles, the 11 and 17-year sunspot cycle. All of those cycles we know are naturally occurring, and we know their frequency in which they do occur. So with the periodicity at which these events occur, we can kind of parameterize those in our climate models and then extract them out to see what the natural variation is versus other factors that go into it. Personally and scientifically in the literature, there is nothing foundational that supports that 90-year cycle in terms of droughts. There are so many other things that impact the climate system. You have oscillations, the Pacific Decadal Oscillation, Madden-Julian Oscillation. And so from the short term out multi-decadally, all of those oscillations also interact with each other. I don't take a lot of stock in those longer term, the Gleisberg cycle, for instance, but those longer term natural cycles.
Anybody else? Dennis, are you a cycle person?
I like to cycle whenever I get the opportunity, and now that it's warmer, I hope to do more of it. The easy answer is there's two cycles. You get cold in winter and the sun comes up in the morning. And if the sun doesn't come up in the morning, not much else matters.
And the way the atmosphere is built, it's built on pure physics, thermodynamics, and dynamics. Fluids flow, sources and sinks of hot and cold and wet and dry, based on physics. So it's hard to look at these longer term cycles and say that there's anything in the natural cycle or natural system that allows that to happen.
Another question that popped up, any long-term forecasts for wind conditions? How do you address the projections or forecasts for wind?
Yeah, there's an interesting article in Nature a few years ago, or maybe recently. Given the amount of CO2 that's being emitted into the atmosphere, as we know, plants absorb that in terms of their photosynthetic cycle. So we're actually seeing greater growth of trees and vegetation when you have trees and vegetation growing at a faster rate across the mid-latitudes, you're actually impacting surface friction. So you're seeing wind speeds actually decrease near the surface in this study, but we're also seeing an increase in wind speed about 200 to 300 feet up, which is turbine height. So we see more turbine farms coming into play from Texas all the way up our way. So I think Gene Tockley also has a great set of studies about wind speeds across the Midwest.
Okay. Question, what does it take to get us out of drought? How much rain over how much time drives down drought conditions? I know, part of it is the quantity of rain. Part of it is the time distribution of rain. As I point out to people, sometimes we get an average of 30 inches of rain, say a year in Iowa. If we got 30 inches of rain in a month, it'd be about average for the year, but it would be a terrible, terrible thing. It depends, rainfall depends on how it's distributed temporally. So, gentlemen, Dennis, Justin, what do you think?
For this, because in his past life, he was a state climatologist of South Dakota, and I would say a drought expert. There are various types of drought. You have meteorological drought, lack of precipitation, agricultural drought, when you start to get moisture stress because of lack of precipitation, and crops starting their physiological processes using subsoil moisture along with the timely rainfalls. When you get into precipitation deficits on a long-term scale, you start to get into hydrological drought, and then you get into economical drought once all those factors start coming into play. So there ecological, sorry. So there are all kinds of factors that go into the temporal scale of drought, but also where it's occurring and how precipitation deficits can remedy it. Dennis?
That's really it. I mean, it doesn't, you can't come in one shot. It has to be a period of repeated rainfalls that are near to above average to improve it. We can come up with a number that says, because NOAA has a map that inches of precipitation to come out of drought, but it's not one answer. It's not one answer. It's a multivaried answer depending on the situation. So to actually remove categories on the drought monitor, we would need several weeks of regular precipitation at or above average, and refilling of the soil moisture profile, and alleviating some of the other issues that we would start saying, okay, the drought is easing and getting better.
Yeah, I oftentimes will have conversations with folks and remind them that it takes a long time to get into a drought. It's not like you sit here normally and then 1 week later you're in a drought. Unlike flooding, which can come, as Jeff and Michael Espy would tell you, flooding can happen overnight. Drought takes a long time to get into it. And on the flip side, it can take a long time to get out of drought. So it's not, I remember even in 2012 and 2013, in the height of the worst drought, we would get a thunderstorm somewhere and somebody would invariably call from some newspaper and say, so we got a bunch of rain, we must be out of the drought. And I would remind them that it takes a long time to get out of a drought, just like it takes a long time to get into one. And as Dennis and others have pointed out in this webinar, what we really need is to see normal to above normal rainfall over an extended period of time to get conditions back to where they're not showing drought, and not so much rain that we end up tipping the scales over into flooding. Anybody else want to wade into that one? So I think we're okay on that. Will increased wind from turbines accelerate drying of soil in the summer?
It can, because when you have the turbines spinning, now the turbines are responding to wind. So they're not creating the wind, but they do mix the atmosphere, and they mix the atmosphere from above down closer to the surface. So they can dry out the soil a little bit more, depending on your situation. Really depends on what your crop situation is, how much of a crop canopy cover there is, and your larger wind situation. So they can a little bit, but they're not going to create drought.
I think we got all of the questions that were typed into the Q&A box. Anything else that presenters want to add? Were any of you sitting there thinking, oh, I forgot to mention something, or something that somebody else said made me think of something else?
Tim, there was one person had a question about the link to the monthly webinars. I did share that in the chat box. Just wanted to make sure
I put it over in the Q&A, so it should be. Did I copy that over? I thought I copied that over, because the chat box is not available to everybody else. At any rate, the monthly webinar information will be available on the information that gets posted next week. And I would highly encourage anyone who's interested in that kind of information to register for those and get tuned in once a month. They're highly informative. As Dennis indicated, they're hosted by a different state climatologist every month. So you get a perspective from Kentucky and Indiana and Illinois and Colorado and the Dakotas. So it's a great further introduction and entrenchment in that sort of information. So if this is of interest or value to you, I would highly encourage you to do that. This webinar is, in a way, sort of an Iowa-centric version of what those Midwest climate updates do every month. I will. Oh, Dennis, did you want to answer that question, or the link to the monthly updates? Somewhere I had that. You posted that in the chat box. I don't.
So the length of the webinar,
Dennis,
that would be regionally?
Yeah, Dennis, if you could cut and paste that Midwest climate update stuff into the Q&A, that would be helpful. I thought I put it in there, but maybe I didn't. But we'll get that to you. Anybody else have any questions or anything else they want to add as we wind this down? We were kind of hoping to end here around 2:30-ish or 2:45-ish. Okay. Well, I appreciate the panelists taking the time to present the information and prepare it and all that today. I'm glad everybody joined us. At one point, there were 45 or so people on the webinar, so it's of interest to folks. Appreciate you guys responding to the poll information. I will pull that information out. It looked like at first glance that there may be interest in continuing these. We will obviously be monitoring drought conditions and climate conditions across the state, and hopefully if things, well, we'll say hopefully, if things continue to look tough in parts of the state, we'll continue to bring information to you on a regular basis, and maybe we'll repeat this webinar as we get a little bit farther down the road. So again, it looks like we got most everything answered. I still don't know if I saw the monthly update link information on here. Let's see, did you put it? Yeah, Dennis, I put it on there. Yep, it shows up under there. I just have to click the box. So the monthly update link should be on there.
And Virgil did chime in and say they could see the chat, but they couldn't respond to it.
Okay.
So
okay.
if they hit the chat down at the bottom, you should see the link to it there. And if not, send me an
good.
email, I'll get it to you.
Yep. And as I say, if you go to the DNR website on Monday or Tuesday, and there's a little search box on the DNR website, and you can just type in water summary update. It'll take you to the page where all the information is linked for these webinars. The presentations from the webinar or the Zoom meeting we had back in January are there, and we'll have these presentations available on that website as well early next week. And you can always reach out to me or anybody else who wants to, who can answer that stuff. I guess Megan put that information up on the website. So there you go. If there's nothing else, I appreciate it. Hopefully you guys can get out and enjoy the great weather. And we'll pray for a little bit of rain up in Northwest Iowa. And we will see everybody the next go around. Thanks, everyone. Have a great afternoon.